poles of equal height are standing opposite each other. So I'll just draw as I'm reading. So I have two poles of equal height. So I have one pole here and another pole here. Remember, they said of equal heights. I'll mark the poles. One is PQ and the other one is AB. On either side of a road which is 80 meter wide. So this must be the road. They're on the either side of the road, 80 meter wide. So this is 80 meter. From a point between them on a road, so if I take a point between them on a road, this is the point P. The angle of elevation of the top of the poles are 60 and 30. So angle of elevation, which means from point P, I am looking here, this is my line of sight at the top of the pole. This is one top of the pole and this is the other top of the pole. And the angle of elevation is 60 and 30 respectively. So for one pole, this is the angle of line of sight. This angle, they said, is one is 30, you can take any of them. And the other angle of elevation. Angle of elevation, remember, you have to draw your line of sight. This is your line of sight. And the angle with the horizontal is angle of elevation. So this is 60. This is your horizontal. Horizontal with angle of, with line of sight. Here, horizontal with line of sight. And these are your, this I'll put as H. I don't know the height. So this is your diagram. Now you got to find the H. Hope you've understood the angle of elevation. I repeat again about angle of elevation. They said from point P, the angle of elevation is 30 and 60. So first you draw your line of sight. Here is your line of sight. And then you draw the horizontal, mark the horizontal. This angle between the line of sight and horizontal will be one angle of elevation. And on the other side, you draw the line of sight because you're looking at the top of the pole. And this is your horizontal. Always draw horizontal for angle of elevation or angle of depression. And this, the angle between the horizontal and the line of sight will be the angle of elevation, which is 60 in this case. So here's a diagram again. The two poles, one is PQ and then we have AB. So we write that PQ, this is PQ. PQ and AB represents the pole. Then we have point of observation. This point here, say R, is a point of observation. And then they talk about the road, and the road here is, this is the road QB or BQ, represents road. So here's a figure. In all these sums, first we choose two triangles. We need to choose one triangle that has got this angle 60, for which we are going to choose the triangle PQR. Now in triangle PQR, we need to mark a perpendicular and our base. So here will be the perpendicular for 60. This is perpendicular, PQ is perpendicular, QR is base. So let's write that out. So in triangle, why have we chosen triangle PQR? Because it has angle 60. So that is, this is PRQ equal to 60. Now the perpendicular is PQ, in this case, which we have taken as h, and the base is QR, which is also not given, and in this case I am going to take it as x. This QR I am going to take as x here. I will take it as x, and then we do 10, tan theta is perpendicular over base. In this case we have tan of theta is 60, perpendicular is PQ, base QR, so which is h over x. So tan 60 is root 3. Root 3 is h over x, and x equal to h over root 3. So we just keep this, we need this a little later. Now the next triangle will be the one with 30, and you agree it is this triangle that we need to work with now. That is triangle ABR, where the angle ARB equal to 30. Here again we got to denote which is perpendicular, which is base. Now for 30, this is a perpendicular here, and here is a base. In this case, I'll tell you right now, I'm going to take the base as y. Here I'm going to take this as y. It's not given to me. The base as y. So let's mark our perpendicular, and for this triangle we'll see who's the perpendicular, which is the base. We said the perpendicular was AB, which is also h meters. Here h meters, equal height, and the base is y meter, and we do 10 theta is perpendicular over base. In this case the perpendicular we know is AB, and the base is BR. So here base, which is BR here. So we have BR, and tan 30 here, the tan theta is tan 30 equal to AB over BR. AB is h and BR is y. Tan 30 is y, 1 by root 3 is h over y, which means y equal to h root 3. So this is my second. I know my x and I know my y. Now to go back, this was my x. I had taken this as x, q, r as x, and I found the x as h over root 3. And the other part, this was taken as y, and I found the y as h into root 3. And if you recollect the road, the entire road, this was the entire road beginning here to here. This was the road, and the road was given as 80 meter. So now you can make an equation. 80 meter will be x plus y. This was x here, and this was y. So let me solve it now. So 80 equal to x, h over a root 3, and this is h root 3. So 80 equal to, take h common out, 1 over a root 3 plus a root 3. So 80 equal to h, I'm going to take LCM, 1 plus 3 over root 3. Cross multiply, 80 root 3, 3 plus 1 is 4, equal to h. So the height h is 20 root 3 meter. So we have found the height. We are not done with the sum. We need to find the distance too. So now we found the height h is 20 root 3. We need to find the distance. If you remember, this distance was taken as x. and x was h over root 3. So let's put the value. H is 20 root 3 over root 3. So h equal to 20. So we put this as r here. So we had QR equal to 20 meter. Now to find the other side, this side, it's remaining. So that is BR, right? So BR will be 80 minus 20, which is 60 meter. Because you know the entire road BQ is 80. So BR is 60 meter. To go over the sum again, we took this triangle here. We took 60, with the help of 60 and 10, we found the value of this x. Yeah, this x we found. Then we went up to the other triangle which has got the 30. This was a triangle that has got 30. And with the help of 10, we found y. And that whole road, which was 80 meters, that entire road, this whole thing was 80 meters. And then we did 80 equal to x plus y. We worked the sum and we got it. For this sum, the figure is given to us. A TV tower stands vertically on the bank of a canal. So we need to draw that first or mark it. So here is our TV tower. This is the TV tower. And it is standing on the bank of the canal. So BC is a canal. From the point on the other bank directly opposite the tower. So we got to take a point which is directly opposite the on the other bank, right? So here is one point C on one bank. They said the angle of elevation is 60. Now how do you draw angle of elevation? You mark the horizontal and the line of sight. This will be your angle of elevation. So let's mark here. Now which is the horizontal here? Here, this is the horizontal, right? And here is your line of sight. This is the line of sight, looking at the top of the TV tower. So here is the line of sight. And the angle between the line of sight and the horizontal, so this angle is 60. From another point 20 meters away from this point on a line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30. Means now we go back another 20 meters, and from this point D again we make angle of elevation. To make angle of elevation, I repeat again, you need to mark your horizontal, and this is your line of sight. This is where you're looking. This is your angle of elevation. Let's mark that in the figure. So here we have marked the horizontal, and now the line of sight, this is your line of sight. You're looking up here. This is the line of sight here. The angle between them is 30 degrees. So this is your angle of elevation. And we need to find the height of the tower and the width of the canal. So we first write down AB represents the tower. Then we're talking about the canal. BC represents the canal. And we have 2 points of observation. First, the person is at C. C is point of observation. And when he is at C, he is making at an angle of 60. Angle of elevation here equal to 60, and then we have D is another point of observation, and here too angle of elevation is 30. So this is our figure, and let's get on with the sum now. As always, we start with two triangles. Now first we have to identify which two triangles are we going to work with in this sum. And to know which triangles, first you have to know which are the angles. One angle was 60. Now this 60 belongs to the triangle, to this triangle ABC, right? So we're going to start with triangle ABC. So triangle ABC. As usual, we know the theta in ABC, the angle is 60. We have to find who is the perpendicular, who is the base. So at 60, we know that the perpendicular here is AB, we call it H. So this is the perpendicular here, and here is the base. The base is not given to us, so we take the base as X. So our perpendicular for 60 is AB, and we have taken it as H, and the base is BC, and we have taken it as X meter. We start with 10 theta, perpendicular over base, which means 10 60, perpendicular we see is AB over BC, which is H over X. 10 60 is root 3. Root 3 is H over X. So root 3x equal to H, and we're going to use this a little later. Now it's time to take up the next triangle. So the next triangle will be with the next angle, which is now 30, and you'll agree the triangle will be this AB, T will be the triangle. So we take up triangle ABD, and in this the theta is 30. We've got to mark a perpendicular and our base. So here is the perpendicular and this is the base. Earlier we have taken AB as H, so we have to keep it as H, and BC we have taken as Y, so as X, so we keep it as X. So we need to find the perpendicular base in this. So in this triangle of ABD, we see the perpendicular is AB, which is H, and the base is BD, which is H plus 20. And hope you have understood why it is H plus 20. See here, X plus 20, your BD. See, this is your X here, and then you add up 20. X plus 20 will be your BD. We now have 10 theta. 10 theta perpendicular over base. In this case, our theta 10 of 30. Perpendicular AB, base BD. 10 theta 1 by root 3. We know AB is H and BD is X plus 20. Cross multiply. X plus 20 over root 3 equal to H. So we got H. By now you will realize we have two values of H. We've got H out here and we've got H out here. So in this next part I'm going to equate for H. So I'll do root 3x equal to X plus 20 over root 3. I cross multiply. Root 3x root 3 equal to H plus 20. Root 3 into root 3 is 3. 3x equal to H plus 20. Here you get 3x minus x, that is 2x, equal to 20, and your x was 10. And your x was the width of the canal. So width of canal equal to 10 meter. Now you got to find the height, and I'm just going to squeeze it in this only. See here the height, we can do, see height was root 3x, right? And we know x was 10, so this would be 10 root 3 meter. This would be the height of the tower. You just put the value of the x. We found the value of x here as 10, and so h equal to 10 root 3. So let us summarize the sum. The biggest challenge in the sum is to draw the diagram right. And then you take, once you got to draw the diagram right, then it's quite easy to do it. So your first two triangles, we first took up the triangle with 60. This was a triangle with 60. We took here as h, and this was x. We used 10 and we found the value of h. So in triangle ABC, we found h equal to something. Then we took the other triangle with 30, and this was a triangle with 30. So again in this triangle of ADB, we found h also with the 1030. We took 1030. We did h over x plus 20, perpendicular over base, and here also we did 1060 equal h over x. And then we equated for h. We found h in both the cases, and we equated for h, and we got the answer. Because h was the common side. This is one of the strategies you use. This h is common for both the triangles, have you seen? So you equate for h. Now for the 12th sum. Just remember, the key in this sum is to draw your diagram figure right. And while drawing the figure, you just have to represent whatever is given in words in your diagram. So just follow the problem. Here, from the top of a 7-meter high building. So I need a 7-meter high building. So this is my ground here. And I'm taking a 7-meter high building. I'm going to call it A, B, and I know it is 7 meters. So AB is my building. Maybe I should write here building. Okay, so I've drawn that. The angle of elevation of the top of a cable tower is 60. So I need a cable tower now. So I'm going to draw a cable tower. So this is my cable tower. Let me write there, cable tower. And again, let me read now. From the top of a 7-meter high building. So my observation, where am I observing? From the top. This is the top of the building. From the top of the building, let me underline that. From the top of a 7-meter high building, the angle of elevation of the top of the cable tower. So from the top of the building, I am looking at the top of the cable tower. This is top of the tower. So this is where is my line of sight. Top of the building to the top of the cable tower. This is where I am looking. And they said the angle of elevation is 60. Now remember, when I draw angle of elevation, I have to first mark my horizontal and then my line of sight, and the angle between that is my angle of elevation. So here I have already drawn my line of sight. This is my line of sight, right? This is, I'm looking top of the building to top of the tower. Now I need to draw my horizontal. So where will my horizontal be? This would be my horizontal. So the angle between this horizontal and the line of sight, so this is my 60 here. So I've taken one angle. Now they've given us another angle. The angle of depression of its foot is 45. So from the same place here, I'm at the top of the building. Now I'm looking at the foot of the tower. Where is the foot of the tower? Here is the foot of the tower. I'll mark the tower as CD. So now I'm looking at the foot of the tower. So right from here, top of the building, I am looking at the foot of the tower. This is my line of sight. And definitely if I'm looking down, I am making an angle of depression. Now, how do I draw an angle of depression? I have to draw always horizontal. So here is my horizontal. And I'm looking down. So this is my angle of depression. So let me mark that. So this is my line of sight here. And here is my horizontal. So this is my angle of depression. And my angle of depression, they said, is 45 degrees. So this is my figure. And this is 7 meters. I got to determine the height of the tower. So my question is to find this entire height of the tower. So here's a neater diagram. Let's just go over this diagram again now. Here was my building. AB is the building. Then CD is the tower. And I was at the top of this building. From the top of the building, I'm looking at the top of the tower here. And the angle we are making is 60. This, of course, is a horizontal. You need to draw your horizontal. And from that same place on the top of the building, now I'm looking at the bottom foot of the tower. Here is a foot of the tower. And as I look at the foot of the tower, I make angle of depression. And remember, the angle of depression is horizontal. Always mark horizontal first. Horizontal with the line of sight. This is your line of sight. And this angle is 45. So now we get on with the sum. Before that, we need to write that AB represents building, which is 7 meters high. CD represents the tower. And then you got to write from A, the angle of elevation to the top of the tower is 60, to top of tower equal to 60, and mark the angle. Say angle CA, I will put this point as E, equal to 60. In the same manner, you will say from A, the angle of depression to the bottom of or the foot of the tower is 45. Therefore, angle EAD equal to 45 degrees. So here's a figure. Now again, we've got to spot the two triangles that we want to work with. Now one triangle will be with 45. So, and the one with 45, you agree, will be this triangle. This would be the triangle with 45. So I'll write triangle AED, and the theta here is 45. We need to mark the perpendicular and the base of 45. This is perpendicular, and here is the base. So we write that now. Perpendicular, we need to base. Perpendicular is DE, which is also 7 meters, because 7 and this also will be 7, right? So this will be 7 meter. This 7, AE equal to 7 was given to us. AB equal to 7 was given to us. And AB equal to D, so that is 7. The base is AE, which we don't know, and we keep it as AE. This is our question, okay? So we start 10 theta, perpendicular over base. In this case, our theta is 45, so 10 45. Perpendicular we saw in this case is DE, the base is AE. 10 45 is 1, DE is 7, and this is AE. So we have now AE as 7 meter. Let me mark that. So I'll raise this up and I write here 7 meter. I have found this as 7 meter. This is one part. Now we've got to take the other triangle. For the other triangle will be the one with 60. Now which triangle is at 60? here, this triangle. So we have triangle AEC, where the theta is 60. Again, we have to know what is perpendicular, what is the base. Now for 60, who is the perpendicular? Here is the perpendicular. And this is the base. Now in this case, the perpendicular we do not know, so we just put a question. However, the perpendicular we know is CE, but we don't know its measure. The base we know is AE, and we found out the measure 7 meter. In the earlier, here we found out AE is 7 meter, and we are using it now in the next triangle. Now we start with 10 theta, perpendicular over base. Here our theta is 60, so 10 60, perpendicular CE, base AE. 1060, if you remember, is root 3. CE we don't know. AE is 7. So 7 root 3 equal to CE. So this is now 7 root 3. We need to find the entire height of the tower. Now the height of the tower consists of DE and then CE. So let's write that. So tower, height of tower equal to DE plus CE. Now DE we know is 7 and CE we found as 7 root 3 now here, right? This we know is 7 and this part we have already found here, 7 root 3. So we need to add them. So that is D is 7, common out, 1 plus root 3. So this is the height of your tower, 7 plus root 3. Now to summarize the sum, we first took 45, and because 45 we took this triangle. In the first case, that was triangle AED. Then we used 10, 45. And we found AE. We did 10, 45 equal to DE, which is 7 over AE. And we found AE as 7. So we found this as 7. We put it up here, 7. Then we took up 60 here and took up this triangle. Again we use 1060 here, this triangle, that is triangle AEC, and we took up 1060. 1060 perpendicular over base, so CE over AE. And we calculated this. It was root 3, your CE you do not know, but AE was already 7 because we found out earlier. And you found CE 7 root 3. And then you added up both. This was 7 root 3, and then this was 7. You added up, you got the entire tower. Is observed from the top of a 75-meter high lighthouse. So let's draw the lighthouse, which is 75 meters high. So this is the horizontal, and we're going to draw the lighthouse, which is 75 meter high. We'll mark the lighthouse as A, B, and we'll write it here, lighthouse. It is 75 meters high, so we've done that. From the sea level, the angle of depression of two ships is 30 and 45. So here there are two ships, so let one ship maybe here. They said if one ship is exactly behind the other, so there's one ship here and there's another ship here. Maybe we should mark the ships as Q, one ship. So this is the ship, and here we have P, which is also another ship. It's given that here they've given the one ship is exactly behind the other on the same side of the lighthouse. And now the angle of depression, they said, is 30 and 45. How do we draw angle of depression? First, we always mark horizontal at the point of observation. Here we are observing, we are drawing the angle of depression. So we first mark the horizontal and then we draw the line of sight. This angle between is our angle of depression. So here we are observing from the top of the lighthouse. So we are observing from A. Let's look at the first ship. So the first ship from A, we are looking at the first ship. Here it will be my line of sight. Now I have to mark the angle of depression. So I need to draw my horizontal at the point of observation. So A is my point of observation, this is my horizontal. So the angle between the horizontal and the line of sight is this angle, right? And this angle will be 45. Now if this is 45, definitely this angle also will be 45. Why? Alternate angles. Now it's time to take up the next ship. Now the next ship, they said the angle of depression is 30. So again I repeat, when I want to draw angle of depression, I first mark my horizontal at my point of observation, and from the horizontal then I do my line of sight. I'm looking down. This angle will be my angle of depression. So let's draw the horizontal at A, and from the same point A, I'm looking at the other ship. So here is a horizontal, and now I have to draw my line of sight. I'm looking at the ship, I'm looking at this ship P now. So this is the angle of depression will be between the horizontal and the line of sight. This angle is 30. Now if this is 30, you definitely agree this angle is also 30 by alternate angles. So this is how I got my figure. I first looked at this ship here. From the same point, I draw the angle of depression. Then I looked at the other ship, which was just behind this ship, and we got our angle of depression. Here was one angle, line of sight with the horizontal, and here also line of sight with the horizontal. So here's the neater figure. So AB was a lighthouse. Here were the two ships, one at Q and one at P, and then we had here, this was a line of sight. This angle was 45. This was 45. Alternate angle, this also is 45. And here we had the other line of sight looking at this ship. This angle was 30. So here also was 30. And we need to find the distance between the two ships. So basically we need to find PQ. This distance is a PQ. So we need to write all this now. So AB represents lighthouse. P and Q represents the ships, the position of the ships. And then you can write angle, we mark here as X. So XAQ equal to 45, angle of elevation at P, depression at P, and angle XAP equal to 60, angle of depression while watching. This is 30. Oh, I'm doing it, yeah. This is 30. Watching, this is watching Q, and this is watching P, and this is watching Q, right? And then you also have to say the alternate angles, why the angles are equal. You'll say this angle XAQ equal to angle AQP, alternate angles. And on the other side you write angle XAP equal to angle APQ, alternate. So here's the figure. Once again we got to choose our two triangles. So we'll take 45 first. So, and we want 45, the triangle which contains 45 is ABQ. So we start with ABQ. So triangle ABQ, the theta is 45. You have to mark a perpendicular and base for 45. Here is a perpendicular and this is the base. So we write that perpendicular base. The perpendicular is AB, which is given as 75 meter, and the base is PQ, which we don't know. We leave it at that. We start with 10 theta is perpendicular over base. So we have 1045 perpendicular AB, base BQ. 1045 is 175 over BQ. So we have BQ equal to 75. Okay, so we've got one thing. Now let's get on to the next. Next is we deal with 30 degrees. Now if we want 30 degrees, it belongs to the triangle ABP. This triangle. So we have triangle now ABP. The theta is 30. Here again we've got to mark our base and perpendicular. And the perpendicular is this. And for this, the base is here. This is the entire base, which is BP. So we write that perpendicular AB, 75 meter. Base is BP, which we don't know. Question. So 10 theta perpendicular over base. So 10 theta, here theta is 30. So 1030 is AB over BP. 1030 1 by root 3. AB 75, BP we don't know. So BP equal to 75 root 3. Okay, this is important. Now what we need to find here is the distance between the ships, and the distance between the ships is this. There's one ship here and the other ship is at this point, and the distance between the ship is here, PQ. That's what we need to know. So if you see the PQ, I think I should mark it in blue, this PQ. So our PQ will be, if you agree, PQ will be BP minus BQ. Let me explain that part. So we have to find our PQ, and you'll definitely agree a PQ will be this entire BP. From this BP we will subtract BQ, and that's how we'll get PQ. So, and we know our BP here, we found our BP is 75 root 3 minus BQ is 75. So I take 75 common out, root 3 minus 1. So this is the distance between the ships, which is 75 root 3 minus 1 meter. So to summarize the sum, first we took 45, and with the help of 45 and the triangle we found BQ. So we took triangle ABQ, and here we found BQ. Then we took, how did we find BQ? Of course, this span was perpendicular. You did 10, 45 equal to AB over BQ, and you found BQ. Then you took up with 30. With 30, this was a triangle. You took up this triangle here. So you have triangle ABP. You used 1030 and you found AB over BP, and in this you found out your BP. And now it was time to find PQ. So for PQ you will do BP minus PQ, and that was the distance between the two ships. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters from the ground. So here's the girl, and she's 1.2 meter tall. She spots a balloon at a height of 88.2. So here is a balloon, and this height of the balloon is 88.2. The angle of elevation of the balloon from the eyes of the girl at any instant is 60. So again I'm drawing angle of elevation. How do I draw angle of elevation? First I draw my horizontal at the point of observation, and I draw the line of sight. This is my angle of elevation. So I draw my horizontal. This is the girl, she's watching from here. This is the horizontal, and here is the line of sight. This is the line of sight, and the angle is 60. So this angle is 60. This is one part. Now the next part says, after some time the angle reduces to 30 degrees. So the balloon would have like moved in the wind, and now it would have occupied this position further away. And now again the girl is watching at the balloon, and she's making an angle of 30 degrees now. So again I am going to first draw the horizontal and then the line of sight, and that will give me my angle of elevation, which is 30 degrees. So let me draw my horizontal. Now the point of observation is the girl. So here is the girl on the top. It's not on the ground because our eyes are on the top. So we have here the horizontal, and then here she's watching the balloon. So angle between the horizontal and the balloon. This angle here now is 30 degrees. Right? The height of the balloon, of course, remains the same. Here we assume that the height remains the same, that is 88.2. Now we must know the distance the balloon has traveled. Now the balloon has traveled was at this point here first to this point, right? So this is the distance the balloon has traveled, which is equal, actually this is the distance, which is equal to this distance. If we calculate this distance, and this is equal. So this is how we go about this sum. So here's a neat diagram. This is the girl here, and she watches the balloon first in this position. So we have this triangle, and then the balloon moves away and she watches the balloon now here making a different angle, right? And this is the ground. So while writing it, so here we need to say A is the first position of the balloon, then B is the second position, of balloon. Then maybe you can also write about the angle of elevation, which is the angle of elevation at A. What is the angle of elevation? At B, what is the angle of elevation? And the height equal to 88.2. So like all the other sums, first let us take up the triangle with 60. So here is 60. And this is the triangle. This side A, then we have mark this point as B, mark this point as C. So we have triangle ABC, where our theta is 60. We have to mark a perpendicular and base. This is perpendicular and here is the base. Now another important point is we have 88.2. 88.2 is this entire height. 88.2. But remember, the girl is 1.2. This part is 1.2. Which means the perpendicular, which we take in this case as P is AB, the perpendicular is AB, will be 88.2 minus 1.2. And perpendicular will be 87. AB 87. So we cannot take perpendicular 88.2 because we have to subtract this 1.2, and when we subtract this 1.2, now this becomes 87. The base we don't know. The base here is BC, which we do not know, and as usual we start with tan theta. Tan theta perpendicular over base. In this case tan theta is tan 60, perpendicular is AB and base is BC. Tan 60 is root 3, AB is 87 and over BC. So we have BC equal to 87 over root 3. We've taken one, we need this later. Now we'll take up the next triangle with 30. So here is 30, and the triangle with 30 will be this. So let's write that up. So triangle, here this is B, and here we have Q, not B, we'll take it P here, Q and C. So triangle PQC. Now in PQC we have the theta is 30 degrees. We must know what is the perpendicular and what is the base. Here the perpendicular is PQ and the base is here QC. Now again the perpendicular is not 88.2 because 88.2 is this entire height. From 88.2 I need to subtract 1.2. This is my perpendicular from here to here, and this is 87. So PQ is 87, not 88.2. So we do tan theta equal to perpendicular over base. In this case our tan is 30, perpendicular 87, base QC. Tan 30 1 by root 3, 87 over QC. So QC is 87 root 3. 87 root 3. So we found PC and QC. Now we have to find this distance traveled from here to here. This distance traveled by the balloon, which is also equal to this distance. Yeah, this distance. And that to find the distance, we mark the distance as BQ. This is BQ. So now next step we have to find BQ. Q, which is the distance. So remember, our aim is to find BQ. And to find BQ, how do we find BQ? First, we know this entire is 87 root 3. We found it. And from there, we will now subtract BC. This we will subtract to get our BQ. So we'll write down now BQ will be QC, that entire, minus BC. Now QC we have found earlier is 87 root 3 minus BC. Now you know, for BC I'm going to make a little change. BC was we found as 87 over root 3. So I'm going to rationalize it. So 87 over, I rationalize it because this is divisible by 3. So we have 87 root 3 over 3. And that works as 29 root 3. It makes the calculation a little easier. So this is 29 root 3. And the answer of BQ is the distance traveled by the balloon is 58 root 3. So distance traveled by balloon equal to 58 root 3 meter. Now to summarize the sum, this was the figure. We first took up the angle with 60. We took up this angle here. And we used 1060 as usual. 1060. We saw, remember this was 87. This is very important. This is not 88. So it was 87 over BC. And then we found BC as 87 over root 3. Then we went on the other side with 30. And with 30 we found this triangle. In this triangle we did here also 10, 30. That is, remember this 88 is for the whole. We don't use 88. We use 87. We subtract 1.2, the height of the girl. And that would be 87 over QC. And we found our QC is 87 root 3. Then we need to find this distance, BQ. BQ, we did this entire distance, which is this one, full one, which is here 87 root 3. And we subtracted it from this distance, and that is 87 over root 3. Of course, we rationalized 87 over root 3 to make things easier, and then we got our answer as 20, we got our answer as 58 root 3. That was the distance traveled by the balloon. Again, for the sum, we need to draw as we're reading. A straight highway leads to the foot of a tower. So let's draw that. So I need a tower. So this is the tower. And here's a highway. And this highway leads to the foot of the tower. So this is my foot of the tower, okay? Here is the tower. I'll mark it as AB. So this is the top of the tower. A and B. A man is standing at the top of the tower and observes an angle of depression of 30. So where is the man standing? At the top of the tower. And he is observing an angle of depression of a car. So definitely the car has to be down here on the highway, right? So here's the car P, and he's from the top he's observing down. That means he's making an angle of depression of 30. How do we draw angle of depression? First we draw horizontal. It has to be, line of sight has to be down because it is angle of depression. and the angle between horizontal and this line of sight, this angle is angle of depression. In this case it is 30. So let us draw that. So we have a horizontal here, and this man is now watching this car out here like this. So this is his line of sight. This is his line of sight. Now the angle between the horizontal and the line of sight, this was horizontal and the line of sight, is 30. And immediately I'm going to mark this as 30. Why? Alternate angle. So this also is 30. Now for the second part of the sum, which is approaching the tower with a uniform speed. So this car is moving towards the tower with uniform speed. 6 seconds later, the angle of depression is found to be 60. So the car has moved away, maybe somewhere here, is moving towards the tower. So now the car is in this position. And definitely the angle would have changed. Now again we are drawing the angle of depression of 60. How do we draw angle of depression? First we draw the horizontal, then line of sight. Why is it down? Because it is angle of depression. This angle between the horizontal and the line of sight is angle of depression. So let's draw that. So the observing point is A, the man is at A. Here is the horizontal. And now we have to draw the angle of depression. So he is watching this car here, which is now approaching towards the tower. So this is my line of sight. So here is a line of sight, and now the angle has become 60. So this angle is now 60. And I immediately mark here 60 because alternate angle. So this is my figure. The car from P has moved to Q. So here's the figure again. AB was my tower. The car was first at P and then it moved to Q, and the angle of depression changed. First the angle of depression was 30. Remember, this was horizontal with the line of sight. So this was 30, hence this also became 30, alternate angles. And then we had at point Q, again the angle of depression became 60. So here we had the horizontal and this was a line of sight. So this was now 60. This angle also became 60. So this is our diagram. We need to find the time taken for the car to reach from P to Q, this time. So here's the figure. Now in this sum you realize there's no side given to you. So we got to do this a little differently. The time taken for the car to come from P to Q, the time was given as 6 seconds. Let the speed of the car be V. So PQ is the distance. So you know distance is speed into time. It is PQ is the distance, the speed is V, the time is 6. So we'll take PQ as 6V. So this is 6V. And then we have to take the other, that is, look at BQ. We don't know the time here. So the time we take as T. The speed remains the same of the car, that is V. So the distance again is speed into time, and in this case it is BQ, the distance, which is VT. So here we take this as VT. So this is a little different from the rest of the sums, where we take BQ as VT and PQ as 6V. Now keeping this in mind, we do the sum just like any other sum now. So we first take up 60, and with 60 we will take up this triangle ABQ, and in ABQ we have to mark, we'll write down triangle ABQ. The theta is 60. We have to know which is the perpendicular, which is the base. Here is perpendicular. We'll take it as H, and the base is our BQ, right? So perpendicular is AB, which we take as H, and our base is BQ. Remember, here we are taking as VT, and you know how you got that VT. V was our speed, T was the time, so distance was speed into time. So now we do tan theta. Tan theta is perpendicular over base. Here we have tan of 60, perpendicular AB, base BQ. So root 3 equal to H over VT. So H equal to root 3 VT. Now we take up the next triangle, and the next triangle is 60 degrees. So to get 60 degrees, we are going to take the triangle A, B, P, this triangle, right? The green one. Let's darken it a little more. Yeah, we take this triangle up. And we do the same, we work the same method. So here we took triangle ABP. Our theta is 30 degrees. We have to mark our perpendicular, we have to mark our base. Perpendicular is AB, which is H. And now our base here, this is our base. This entire thing is our base, which is BP. And look up and see what is BP. It is BQ plus QP. BQ is VT and PQ is 6V. Let me write it in the color that I've used in the diagram. And we see it is BQ is VT plus PQ is 6V. So the base, that is BP, equal to VT plus 6V. Now we do tan theta, perpendicular over base, and this should be tan 30. I have done it wrongly as tan 60. If you see later, I have corrected it. This is tan 30. So this will be 1 by root 3. So ignore this part. This entire part has to be ignored. Now here's a correction. Tan 30, which is 1 over root 3. Your AB is H and BP is VT plus 6V. So H will be equal to VT plus 6V over a root 3. So this is our H. So we equate for H now. So H equal to H, which means root 3 VT equal to VT plus 6V over root 3. We cross multiply and we'll get root 3 VT into root 3. I'll take V common out here, so it becomes T plus 6. So this becomes 3 VT equal to VT plus 6. V cancels. I'll do it up here. So we have 3T equal to T plus 6, and you get your T equal to 2. Now here we'll get 2T equal to 2T equal to 6. So T equal to 3. To summarize the sum, the first thing we did was to find PQ. To find PQ, we said let the speed of the car be x x, we've taken v meter per second. So time for PQ, for the distance PQ, is 6 seconds. Therefore distance, which in this case is PQ, equal to speed into time, and that is 6v. So PQ was 6v. This was important. So 6v. Then we took up BQ. We said let the time taken to cover BQ be t second. So we know speed is the same. The speed is v meter per second. Therefore distance, which is BQ, equal to speed into time, and this was vt. So then this we wrote as vt. And then we took up this triangle. Here we took this triangle up. We did 10 equal, if we put this h, we did 10, in this case was 1060. We did h over vt, so we did root 3, the h over vt, and h equal to root 3 vt. And on the other side then we took this big triangle with 30 in it. And here too we use 10. 1030 is h over, now in this case we did 6v plus vt because it was an entire BP. So root 3 is h over 6v plus vt. We cross, oh here the same mistake, 1030 is 1 over root 3. So we got h as 6v plus vt over root 3. And then we equated for h. And we got the answer. To equate for h, we did h equal to h, that is root 3 vt equal to 6v plus vt over root 3. Cross multiply, 3 vt, v common out, 6 plus t. You cancel it, 3t equal to 6 plus t, 2t equal to 6, t equal to 3 seconds. The angle of elevation of the top of a tower from 2 points at a distance 4 and 9. So here I have the ground and then I have a tower. So this is the tower, we call it AB, and from 2 points I take one point, say P, and the other point Q. So let's just mark the angle of elevation. Say this is now point P. This will be its angle of elevation. I will call it alpha. They have not given the angle, so I'll just call it alpha. And from Q, here this is Q, here is the angle of elevation. I will call it beta. Now the distance is 4 and 9. So this distance here is 4 meter. And this distance here is 9 meter. They've given us something else. They said these angles are complementary. That means alpha plus beta equal to 90. We'll use this information later. So first we'll take up the triangle. We'll take up the triangle APB. And in APB we'll write 10 alpha. 10 alpha is perpendicular AB over base PB. So 10 alpha, I'll take this as H. Alpha equal to H over 4. Fine. Now we go to the other triangle. The other triangle is the beta triangle, that is AQB. And here 10 beta. 10 beta equal to AB over BQ, and 10 beta equal to H over 9. Now these two equations we need to multiply. 1 and 2 will multiply. The sum is very different from the rest of the sums. So 10 alpha we know is h over 4. We are multiplying, so 10 beta is h over 9. Now here's one property, is 10 alpha. When angles are complementary, 10 alpha will be cot of beta. This is actually not included in the syllabus this time, but I'm just doing it. 10 alpha equal to cot beta. So here for 10 beta, or you can say 10 beta equal to cot alpha. So here I'm putting cot alpha equal to h square over 36. Now 10 and cot will cancel because they are reciprocals. So 1 equal to x square over 36. So I'll do here x square equal to 36 and x equal to plus 6. The minus 6 I ignore because it cannot be negative. Height cannot be negative. So the height of the tower is 6 meters.